Today's topic we are going to learn transportation problem. Some of the student asked me to give a lecture related to the transportation problem. Exactly, that's why we made this video for your better understanding. So, a transportation problem. The term transportation comes from the word transport. That means you just make some quantity transporting from a particular place to another place. Here is a diagrammatical representation of a transportation problem. Here we use some term. One is called the origin or factory, another one is called the destination point or the demand point. Destination point or the demand point. Here is the origin and factory. What represent this? We just represent the origin or factory by their quantity by AI, how many number of quantity produced by this company we represent by AI, and BJ represent the how many demand, how many number of quantity demand for a particular destination point we represent by BJ. And this diagram which shows in this diagram is it's represent that A1, if we consider in the first factory the production produce is 40 unit, and this one represent in the second factory the total number of production produced is 25 unit, and this represent in the third factory the number of production produced is 35 unit. What represent this represent, if we consider in the first destination point the desired quantity or the demand of the first destination point is 30 unit, and for the second destination point is also 30 unit, and the third destination point is also 40 unit. What represent this quantity? This represent if we supply a product from the first factory to first destination point, the unit cost of this product should be 8. What represent this represent if we supply the 1 unit quantity from the first factory to the second factory, the 1 unit cost should be rupees 9 or maybe $9, whatever may be the quantity. And this represent if we supply the 1 unit quantity from the first factory to the third factory, the unit cost should be 7 unit, and so on. This represent the unit cost to supply for a particular origin point to the particular destination point. How is its diagrammatical how can I represent this one? If we consider this is your particular way, or sorry, I just form a matrix here. If we construct a matrix here, okay, then what happen, you should understand. If we draw here a matrix for this particular problem, there is a this. If we represent this one is your origin 1, this one is your origin 2, this one represent the origin 2, the second origin or the factory, and this one represent the third origin. And if this represent the first destination point, is naming as D1, this one represent the second destination point, this one is D2, and this one represent the third destination point, D3. According to this diagrammatical representation, if we make a tabulation form of this problem, what should be there? What should be there? Sorry. So this one is the tabulation form of the given matrix. We start to construct the given matrix here. The first factory production unit is 40, so here we mention 40. This is nothing but A1. This is nothing but A1. Okay, this is nothing but A1. Okay, A, and this one is 1. A1. This one is A2. This one is A3. This one is B1. This one is B1. This one should be B1. This one is B1. Okay, and this one is B2 and this one is B3. For general case we write here BJ. General case we write here BJ, and in that case we write AI. How many quantities supply for the factory? This one is represented by AI. Okay, and how can I construct this table? O1, O2, O3 are the naming of the company, D1, D2, D3 are the naming of the destination point. The first factory production unit is 40 units, so here we mention 40, which is nothing but A1, and the general way of notation of all the supply is AI, so here we use this AI. That means the first factory can supply 40 unit, second factory can supply 25 unit, third factory can supply 35 unit. The first destination point, this one, the demand is 30 units, so here we write the 30 unit. D2 is 30 unit because it's your the second demand point, and this one is your third demand point, so here we represent 40 unit. And how can I input this cost? This represent the unit cost. We have already mentioned, when we supply 1 unit quantity from the first factory to the first destination, the unit cost is 8. When we supply from the first factory to the second destination point, the unit cost is 9, so here we write 9. When we supply the first factory to the third destination point, the unit cost is 7, so here we represent 7. When we supply from the second factory to the first destination point, unit cost is 4, so here we write 4. Exactly in that way, here we write 5. Here we write 5, and this one is second to second, sorry, this one is not 5, this one is 3, only 3, this one is only 3, this one is only 3 here, this one is 3, and this one is 5, this one is 5, and this one is 8. Okay, and this one is 5, this one is 5, and this one is 6. So it is the tabulation form of the corresponding graphical representation of the problem. Exactly, that's why when we solve a problem, the the problem structure should be in that form. Okay, so when we move to the formulation of the transportation problem, if we consider this one, exactly in this one, if we consider x11, you should recognize this one. If we consider x11 is the quantity supply from the first, here we consider x11, the position of the cell, it's a first row first column, so here we replace x11. Here if we consider x12 is the quantity supply from the first factory to the second destination point, and so on. Therefore the number of variable to construct this transportation problem should be 3 into 3, 9. So if we write this transportation problem as a mathematical formulation, here we give the mathematical formulation of this problem. You can easily recognize from this table is that if xij be the quantity transport from ith to jth destination, ith transportation from the ith to jth, that means the ith is the origin point and jth is the destination point, the costing required, if we represent this costing is C11, this costing is C12, 1 2, this costing is C13, and the corresponding quantity supply from the first factory to first destination is X11, X12, X13. Therefore the total costing for supplying this quantity with this particular destination point should be C11x1, C12x2, C13x3, and this one is C21 x21, c22, x22, c23, x23, and so on. So here we write the mathematical formulation of this problem: Cij xij summation over I and j. So here we represent two summation over I and j. One important thing is one thing is very important. If you recognize these things, this one, if we write the first where we supply from the first factory to third destination point is x13, that means the total supply of the first factory to all the destinations should be x11, x12, and x13. That means j is variable, I is fixed. So here we represent the constant under the circumstances. What is the circumstances? x11 plus x12 plus x13 should not exceed 40. Okay, that means here if we write in the general form, that should not exceed a1, because a1 is the total supply they can the supply from the first factory. So if we write summation over j equals to 1 to n, whatever may be the number of destination point, if we take a summation from this, then xij should be lesser equals to ai. That means if we replace I equals to 1, it's become x11, x12, x13, and so on, which is lesser equals to a1. Similarly for the second case, x21, x22, x23 lesser equals to 25, we get another constant. For the restriction of the demand, if a destination point the demand quantity is 30, that means the company must store, the destination point must store at least 30 units. For exactly for that reason, here we write x12 the variable, this one is the x21, this one should be the x31, this one should be the x31. That means the demand point 1 takes supply from the first factory is x11, second factory is x21, and the third factory is x31, and this demand should fulfill its demand, at least it's fulfill its demand. Exactly for that reason, here we consider xij, which is greater equals to bj. Here the value varies from the position of rows, so here we take the summation for I xij, which is greater equals to bj. That is and you can easily recognize that xij should be greater equals to 0, because a company cannot supply the negative number of quantity from a destination point. So the value of xij should be either 0 or greater than 0. The result should be greater equals to 0. Our goal is to supply this quantity with the suitable destination point such that the costing should be minimum. So here we use the objective function z. Our goal is to minimize this. That means the objective function is linear, constant or linear, therefore it's a linear programming problem. Since it's a linear programming problem, you can solve using simplex method, but when you solve using simplex method, you can easily recognize that here the number of factory is 3, therefore the number of constant regarding factory is 3 and destination is 3, so the regarding destination constant should be 3, therefore the total number of constants should be 6. So you have to perform a 6th order identity matrix to start your problem. It's a very tough job to solve a transportation problem using simplex method, but still we solve this problem using simplex method with a different approach of the simplex method. So our goal is to find the different approach of the simplex method. In the next lecture, we move to the procedure of solution, and another very important you can observe from this, it's a very important multiple choice question, is that how many number of constant required to construct a problem. That should be m plus of n. M is the number of origin and n is the number of factory. Here we mention the important note for you. Total number of constants should be this, and how many number of variable required, m into n. That should should be number of origin into number of destination point. That should be the number of variable. That means if a problem is a 5 into 3 5 cross 3 order problem, therefore the number of variable becomes 15.